Hello, I wanted to talk to you guys about solving equations by factoring. So we've spent a lot of time talking about factoring, and really at this point it's just trying to figure out what the prime factors are of a polynomial. But it is far more valuable than that. So one thing that we do with it is solving equations by factoring. So far our experience with solving equations has been things like 2x plus 6 equals, let's say, 14. And our strategy there was we would get the x term to one side and the constant term to the other side, and then we would divide by the coefficient of the variable. So we would say subtract 6 here, and we would get 2x equals 8, and then we would divide by 2, and we would get x equals, divide by 2, and we would get x equals 4 as our solution. But things will be a little bit different when we have something like x squared minus 6x minus 7 because equals 0, let's say, because we can't get the x by itself because there are two occurrences of x here. And so we're going to need a different strategy. Right? And before I tell you what that strategy is, we need to know something, a special property in math, and that is the property that says that if we have two things multiplied together and they give us 0, one of them must be 0. All right, so if a times b equals 0, the only way that can happen is if a equals 0 or b equals 0. So for example, if we played this little game where I said, okay, I'm thinking of two numbers that multiply to 0, you could automatically guess one of them. You couldn't necessarily guarantee, I couldn't guarantee that you could get both of them, but you could always tell me, oh, well, if two things are multiplied together to give you 0, one of them has to be 0. There's no other way to get 0 through multiplication than have one of the two numbers be 0. All right, so that's an incredibly important property that we're going to be using when we do these. Now, that property does not extend beyond 0. There is no property that says that if I have two things that multiply together to give me 1, one of them has to be 1. That's just completely false. For example, one of them could be 1/2 and one could be 2. 1/2 times 2 is 1. There is no property that says if I have a times b equals 5 that one of them has to be 5. I could have one be 25 and one be 1/5, and they would multiply together to give me 5. All right. If this number is not 0, there is no guarantee that either of these is known. All right. In fact, there's a pretty good chance that you would not guess either of them. All right. The only number for which that property is true, that if I know that two things are multiplied together and they give me some number, if that number is 0, you can be guaranteed to know that one of the two numbers is 0. And this applies to if it's a times b times c equals 0. If there's three things multiplied together to give you 0, then one of them has to be 0. So again, it's this product equaling 0 that says one of them has to be 0. So what we're going to do in these polynomial problems that we have is we're always going to try and solve this equation where we have some polynomial equals 0, and we are going to solve that by factoring. All right, let me just show you a quick example right here. So if I factored this, first I would look for a GCF. It doesn't have any. It's not a difference of squares. It is an easy general trinomial. So I'm going to write this. All right, I'm going to put an x here and an x here. I'm going to look for two things that multiply to 7 that subtract to 6. That would be 7 and 1. I notice that this is a negative, so there has to be opposite signs, and this guy decides who the larger one is. So the larger one, the 7 is the negative, and the 1 is the positive. All right. So I factor these. I say, all right, I have two things here that are multiplied together to give me 0. One of them has to be 0. All right, so that says that x minus 7 equals 0 or x plus 1 equals 0. Well, let's take a look at this. If x minus 7 equals 0, if we solve for x the way we did when we had a linear equation like this, we would say, oh, I'm going to add 7 to both sides. X is 7, or I solve this equation. I move the 1 over to the other side as a -1, and I get x equals -1. And what that tells me is that if I substitute 7 back into this equation, I will get the true statement. I will get this equal to 0. Or if I substitute -1 in for x in this equation, I will get a true statement. So let me just show you what that means. I'm going to take this. I've got x squared minus 6x minus 7 equals 0. Right? This is our check like we used to do in pre-algebra when we were learning how to solve linear equations. So I'm going to put in 7. So 7 squared minus 6 times 7 minus 7, is that actually equal to 0? No, that's 49 minus 42 minus 7. Is that equal to 0? 49 minus 42 is 7, and 7 minus 7 is 0, so I get 0 equals 0. Since that is true, this is a true statement, or this is a solution. I could do the same thing again. I could check it for -1. This is saying -1 squared minus 6 times -1 minus 7 should be equal to 0. Let's check it out. This is 1 minus 6, or 6 times -1 is -6, so minus a -6 minus 7, is that equal to 0? 1 minus a -6, that's the same thing as 1 plus 6 minus 7, is that equal to 0? 1 plus 6 is 7, 7 minus 7 is 0, so 0 equals 0. Yes, it works. Right? So again, when we get an equation, same as before, when we get an equation from last year, we were trying to figure out what x value made that true. The same thing is true here. We're trying to figure out what x values make this a true statement. And then we just got two values right here. We checked it just like we would check before. Right? Here are a couple things I would like to point out to you though. Notice the difference. We only got one solution here that worked. All right? It wasn't like it could be 4 and -7 or something. It's just 4. All right, in this case, we got two solutions. All right? Now, notice in this one, we didn't know about exponents last year when we first started solving these, at least not in equations, but notice how this exponent is 1, and we got one solution. And here the highest exponent is a 2, and we got two solutions. Right? That is not coincidental. The exponent indicates how many solutions we should get, real or imaginary. And again, I know you don't know about imaginary yet, so you'll just have to trust me on that. But the exponent tells us how many solutions we should expect. Right? So let me just write that down. The highest exponent in the equation tells us how many solutions real or imaginary we should expect. Now, since you don't know anything about imaginary numbers just yet, we're only going to be looking for real solutions. And because it would throw you off if we got too few solutions because there were imaginary, we're only going to be looking at ones where all the solutions work out properly. In the next, not next chapter, but the chapter after that, we'll look for real numbers that are not rational. And then next year, we'll look for imaginary solutions so that we get this total number of solutions each time we solve an equation. All right, so I have a worksheet for us to work on. So you should have printed that out already, and so this would be the time to get it out. And it looks like this. All right, solving quadratic equations by factoring. So let's just look at a couple of these. And I want to hit some of various levels of difficulty. All right, so let's take a look at numbers 1 and 3 and 5 for right now, and then we will skip down to ones like 11. So at least let's get started on these. Okay, so let's take a look at this. All right, so first of all, notice that the directions say solve, not factor. All right, you can only solve an equation. And so when all the other problems that we have done so far would have just said factor, right? Because we have that equation, we can now change it to solve, right? So the first thing I want you to notice is that we have all our terms on this side, we have the equal sign, and we have a 0. That's exactly the way we want it, right? Because remember, just like that last example we did, we're going to factor this, and we want this to be equal to 0, not 1 or 5 or something else. So we're in really good shape right now. All right, so then we have to factor this in order to get it into a product of things that equals 0. All right, so this is where we go through that same list of factoring that we've tried, or that we've been repeating over and over again. So first thing we do is we look to see if there's a GCF. Hopefully you're saying no, there's not. The second thing we would look for is it a difference of squares? No, it's not. Remember, difference of squares only has 2 terms. This has 3. Next, we would try easy general trinomial. Hopefully you're saying yes, that's it. It's a trinomial. It's easy because the leading coefficient's 1. It's general because of the pattern of the exponents. This is twice as big as this. All right, so then we're going to factor this. Again, I'll do a couple of these on the page, and then I'm going to have to move off because there's just not enough room here. All right, so I'm looking for 2 things that multiply to 18 that add to 9. All right, so I'm thinking of things that multiply to 18. That's 1 and 18, 2 and 9, 3 and 6. That's it. All right, they multiply to 18 and add to 9. So it's going to be x, 3, 9, 3, 6. And then I have to worry about the signs. So this tells me that they're both the same. And this says that they must both be negative then. All right, and again, if you want to just do a quick check, x times x is x squared. Then I'm going to get a negative 6x and a negative 3x, which will give me that negative 9x. And then negative 3 times negative 6 is positive 18. All right. Now I'm going to use the property that says if a times b equals 0, then either a equals 0 or b equals 0. All right, that means we have 2 things multiplied together to give me 0. One of them must be 0. So either x minus 3 must be 0 or x minus 6 equals 0. All right, if x minus 3 is 0, hopefully you can just solve that without having to move it over physically. You should get x equals 3. And if x minus 6 equals 0, then that means that x could equal 6. All right, and those are our 2 solutions. For the first couple of them, I'm going to try them out. But again, just for time's sake, I'm not going to do all of them. So here, let's put 3 in. So we would get 3 squared is 9. We put 3 in here, we get 9 minus 27, that's negative 18, plus 18 is 0. For the second one, we put in 6, we get 6 squared is 36, minus 9 times 6, 9 times 6 is 54, so 36 minus 54 is going to give us negative 18, and negative 18 plus 18 is 0. All right, let me just pause here for just a second. When I say x equals 3 or x equals 6, it doesn't mean that they both will work at the same time. All right, it's either x equals 3 is going to make it true, or x equals 6. Don't try and put 6 in here and 3 in here all at once, or vice versa. That's not going to work. All right, so it's one or the other, and it's not like you have to choose one or the other. It's telling us that either one of these will make it a true statement. It's not like I say you can wear your red shoes or your black boots. You don't get to just pick one, all right? In math, or means something a little bit different. It means that either of them could work, right? It doesn't mean that you have to choose one. Okay, let's look at the next one. All right, so again, we're in a good situation here because we have it set equal to 0. So then we're just going to factor. All right, so I want you to think for just a second about how you would factor that, what technique you would use. All right, hopefully you said that that is a difference of squares. There was no GCF, and it is two terms separated by a minus sign, and both are perfect squares. So this would factor into n minus 8 times n plus 8 equals 0. Now again, I'm using this property that says that if I have a product of two things equaling 0, one of them must be 0. So either n minus 8 must be 0, or n plus 8 must be 0. If n minus 8 is 0, that says that n must be equal to 8. And if n plus 8 equals 0, that must mean that n equals negative 8. And again, I'm just pointing out that our highest exponent was a 2, we got 2 solutions. Our highest exponent was a 2, we got 2 solutions. And again, let's just check one of these. If I put 8 in for n right here, 8 squared is 64, minus 64 does give me 0. All right, this is where the problem starts coming in terms of space. Let me get a new pencil. All right, so we're going to have to be really careful here. I'll do it for this one, but I'm going to run over here. All right, so I'm looking for two things that multiply together. Let me see what this multiplies to. This multiplies to 105. All right, so I'm looking for two things that multiply to 105 that add to 22. All right, again, what I'm not saying here is this is a harder general trinomial, so we've switched our technique. Again, we still have this equal to 0. All right, two things that multiply to 105 that add to 22 are 7 and 15. Again, this is something that you're going to do on your own off on the side, but for time's sake, we're not going to do that here. All right, so the two things are 7 and 15. So I'm going to write this as 35 n squared. Now I have to look at how this works. I want them to add to 22. That means they both have to be the same sign. And because it's positive 22, it means they both have to be positive. So this is going to be plus 7n plus 15n plus 3. Now I do grouping. I'm going to take out a 7n. I get 5n plus 1. And then I have 15n plus 3. I'm going to take out a 3 here, so I get 5n plus 1 again equals 0. I'm going to factor out that 5n plus 1. And I'm left with 7n plus 3. Again, none of this part should be new. I'm not saying it's easy, but this is not new, which is why I'm not going into a whole lot of detail here. All right. So this tells me I have a product of two things equaling 0. One of them must be 0. So either 5n plus 1 equals 0 or 7n plus 3 equals 0. This is the first one where we're actually going to have to do some work here. I'm going to subtract 1, so I get 5n equals negative 1. And I'm going to divide both sides by 5. So this is n equals negative 1/5. These are a lot less fun to check than some of the other ones. Same thing here, I'm going to subtract 3 from both sides, so 7n equals negative 3, and then I'm going to divide by 7. n equals negative 3/7. Right? We'll check one of these, but right now I'm out of time. Okay, let's check one of those two solutions. I'm going to do it on a separate sheet of paper just for space. So let's check n equals negative 1/5. So, do I want you to do this every time? In the ideal world, sure, you would. But if you can check them especially the fraction ones, if you can check them in your answer key. But some of these whole number ones or integers, I definitely would want you to get the practice of checking them. But let me show you what it would look like for the -1/5. All right, so we've got 35 times -1/5 squared plus 22 times -1/5 plus 3. Is that equal to 0? All right, -1/5 times -1/5, that's 1/25. All right, 22 times -1/5, again, it's just numerator times numerator, denominator times denominator, so this becomes -22/5 plus 3. Is that equal to 0? This looks way worse than it actually is, so just hang with me here. This, I notice that there's a 5 in each of them, so I'm going to cancel out a 5 here, and it becomes 5, and here it becomes 7. Now I'm just going to do top times top, bottom times bottom, so this is 7/5 minus 22/5 plus 3 equals 0. Don't bother changing that into an improper fraction with a denominator of 5, because if this is actually supposed to be 0, this better end up being -3. All right, so just hold tight with that. All right, so let's see if that actually does work. 7 minus 22, that actually does give us -15/5 plus 3. Is that equal to 0? -15/5 is -3 plus 3 equals 0. So yes, that actually is a solution to it. And then same with -3/7. We're just not going to check that one. Okay, I want you to pause the video for just a second, and I want you to try number 2 on your own. Okay, hopefully you did all right with that. Again, all these initial problems have this set equal to 0. And so we're really in a good position. We just have to factor this. So this would be, I'm looking for 2 things that multiply to 4 that add to 5. So I've got x plus 4, x plus 1 equals 0. Now I have a product of 2 things equaling 0. One of them must be 0. So either x plus 4 equals 0 or x plus 1 equals 0. And so you should have gotten x equals -4 or x equals -1. Those would be your 2 solutions. Again, highest exponent is a 2. We should be expecting 2 solutions. All right, so again, so far all of these have had the polynomial set equal to 0. But as we scooch down the page, and let's look at number 11 here, that starts to change. All right, so if you notice here, that we've got the x squared on one side and the 11x minus 28 on the other. This is not going to work because, again, we have to have a product of 2 things equaling 0. We don't have this equal to 0. So we're just going to boot everything over to the other side. All right, so this is going to become x squared minus 11x plus 28 equals 0. And now this is exactly like what we just did before. In fact, this is nice because it's an easy general trinomial. So take just a second to go ahead and do that on your own. So pause the video. Okay, so you should have gotten sorry, not x squared. I'm looking for 2 things that multiply to 28 that add to 11. All right, so that would be x minus 7, x minus 4 equals 0. Again, I say I have a product of 2 things equaling 0. One of them has to be 0. So either x minus 7 equals 0 or x minus 4 equals 0. All right, so either x equals 7 or x equals 4. All right, you try one like that, number 12. Pause the video, and I want you to move things over and solve. Okay, if I move that over, I get k squared plus 15k plus 56 equals 0. All right, I'm looking for 2 things that multiply to 56 that add to 15. All right, so think about things that multiply to 56. 1 and 56, 2 and 28. 3 doesn't go into it, 4 goes into it 14 times, no to 5, no to 6, yes to 7, and 8. There you go. All right, so two things that multiply to 56 that add to 15. So we've got k plus 8, k plus 7 equals 0. Again, we've been writing out this step saying that I have a product of two things equaling 0. One of them must be 0, so either k plus 8 equals 0 or k plus 7 equals 0, and then solving to get x, k equals negative 8 or k equals negative 7. I anticipate that at some point you're going to get bored of writing that and you're just going to want to jump right to that step, and that's fine. It might take a little bit longer for you to feel that way when you've got these fractional answers, but eventually you'll get there. For right now, I would say definitely write these out. But if you're feeling already, do I need to write those out or can I just write this? I would say you can just write that if you're ready. Okay, let's try one more of these. And let's make it, hold on, I'm looking for a very specific one. Actually, let's try two more. I want to point out a weird one like this. And then let's try number 19 after that. Okay, so those two. So for number 16, think about what you would do first. Hopefully you're saying that you would take m squared and subtract 2m so that it's set equal to 0. And then this type of factoring for some reason really throws people off when they see that. They're not quite sure what to do. So think for just a minute, what would you do to factor that? Again, if you've gotten to the point where you keep going through those steps that I've told you, you're going to look at that and say, first I should try GCF. Oh, yeah, that's actually it. Right, so pull out the common factor of m, and then m minus 2 equals 0. Right, now I have a product of two things equaling 0. It just happens that this thing is not a binomial like we're used to, but that's okay. All right, so I have a product of two things equaling 0. One of them has to be 0, so either m has to be 0 or m minus 2 has to be 0. Well, if m is 0, there's nothing more to do. M is 0. If m minus 2 is 0, then we get m equals 2. Let's check that back in the original equation. If I put in 0 here, is 0 squared equal to 2 times 0? Yeah, it is. I get 0 equals 0. If m is 2, is 2 squared equal to 2 times 2? Yeah, 2 squared is 4, 2 times 2 is 4. So yes, these are our solutions. All right, let's take a look at number 19. And then I won't make you do any more of these with me. I'll let you do some on your own. Okay, so for 19, we're going to notice that this is not 0, so we need to put it on the same side as everything else. So we're going to get 10x squared minus 26x plus 12 equals 0. All right. I want you to notice, again, if you're going through those steps as I've asked you to do, the first thing you should check is to see if you can take out a common factor. And in this one, this is the first one that we've done where you can do that, you can actually take out a 2. Right, so there's a 2 in here, and in here, and in here. Now, there's two different ways you can do it. One is you can say, oh, let me factor it out. Right, so you could say 2, and this is 5x squared minus 26, nope, minus 13x plus 6 equals 0. All right, that's one way you could do it. All right, and then you could just factor this normally, right? I don't particularly love this method, although I understand why you're doing it. And here's why. Because sometimes people get confused at the end. Like, let's say whatever we factor this into, we've got 2 times something equals 0. First of all, it's 3 things that are being multiplied together. So sometimes that freaks people out a little bit. Second of all, let's say, again, I'm just going to totally make this up. 5x minus 3 and x minus 2. I don't know if that's it or not. It actually is. But So you might say, I have 3 things multiplied together to give me 0. X minus 2 equals 0, 5x minus 3 equals 0, or 2 equals 0, and people are weirded out by that, right? 2 can't be 0, right? So that's one reason I don't like you factoring it out like this, but it's understandable. The second thing that you could do is just say, again, we'll do more of these in class, but I just want to point this out. The next thing I could notice is that, well, if I have 2 things multiplying together to give me 0, I just promised that you could tell me what at least one of them was. All right, so 2 things multiplied together to give me 0, one of them has to be 0. Well, this isn't it. All right, there's no way that 2 could equal 0. So at this point, you can just drop it. All right, so this becomes 5x squared minus 13x plus 6 equals 0. All right, that's another way that you can think of it. The third way that you could think of it is right back up here where it's 10x squared minus 26x plus 12 equals 0. And I can say I'm allowed to divide both sides by anything I want as long as it's equal, and I'm going to divide everything by 2. All right, if I divide 10x squared by 2, I get 5x squared. If I divide negative 26x by 2, I get negative 13x. If I divide 12 by 2, I get 6. If I divide 0 by 2, I get 0. I go right from here to here. That's what I would prefer you do. If you notice that it has a common factor, because this is equal and I have 2 sides that I can do the same thing to, I can divide everything by that common factor as long as it's just a number. All right, as long as it's just a number. If it's also got a variable in it, you can't do it because you can't divide by x. Again, we'll look at more detail in class when we do these together. But for right now, I just want you to see, my preference would be if you see a numerical GCF, divide everything by it, including the 0, because it's not going to be affected. All right, so now we're at this point. We're looking for 2 things that multiply to 30 that add to 13. All right, hopefully you said 10 and 3. 10 and 3 add to 13, and they also multiply to 30. So this is going to be 5x squared. They both have to be the same sign because it's positive, and that sign has to be negative. So this is going to be minus 10x minus 3x plus 6 equals 0. I'm going to do grouping here, but I'm going to have to change this to plus a negative 3x right here so that that negative can get grouped in there. All right, I'm going to take out a 5x from here. This is x minus 2. I'm going to take out a minus 3, a negative 3 from here, and this is going to be x minus 2. Right, now I'm going to take out the x minus 2's, and I'm going to get x minus 2 times 5x minus 3 equals 0. Right, now I have either x minus 2 equals 0 or 5x minus 3 equals 0. This is going to tell us that x equals 2, or this one's going to take a little bit more work. Let me add the 3 to both sides and divide by 5. All right, so those are our 2 solutions. All right, again, my point here was if we have a GCF and it's just a number, please divide every term by it to get rid of it. All right, but again, we'll talk about some more of these. We'll talk about more variations on them. What if there's parentheses in there? What if the terms are in the wrong order? What if we have a highest exponent of 3? All sorts of things that we can do to make these a little bit more challenging than the ones that are on this page. Not saying they weren't hard, but I'm just saying we can actually jazz these up a little bit more. All right, I'll see you later.